Live. Excellent. Excellent, excellent. Do you guys know what Carvana is? Yeah. So total coincidence. I'm having you guys do this project. I typically drive a 2005 Honda Civic. And Honda Civics tend to last forever. But like the one that I got, like I didn't get it in 2005. I got it in like 2015 or something like that. It was already 10 years old when I got it. And the most recent trip to the mechanic, and I found out that 2005 Honda Civic needed over $1,000 worth of repairs. Compare that to the trade-in value of the car, and I am not getting my money's worth. I'm putting in more money into repairing this car than what it is worth. So my wife and I had to make the decision. Now, I was out of school Wednesday, Thursday, Friday. Due to side effects of the vaccination and whatnot. You're good. Thank you. But so I realized, we need to get a new car. But I don't want to go to like these like car dealerships and stuff like that. So we start searching online, and we had been recommended Carvana.com. And I'm like, okay, so I go on Carvana.com. I am so skeptical. It's like basically vending machine cars, I am so skeptical of this site. But the more I look into it and the more I read into the fine print, I'm like, this is actually something. So on last Thursday, we found, after searching for, a few hours, we found the car that we thought, okay, this is the one. We put in all of the information. We clicked to purchase, and they're like, would you like it shipped tomorrow? And we're like, yes. So ordered it on Thursday, got it on Friday. Like, you've got to be kidding me. Like, so we're going to take it to the mechanic tomorrow just to do a once over. And then if that's fine, then that car is ours because we have 7 days to decide. It's like vending machine cars. What the heck? That's pretty sweet. I don't know. Just saying. So we now have a 2016 Nissan. Very exciting. My son enjoys the color and the third row seating, but I digress. Oh, speaking of cars, you have a project due today. No excitement. Okay, all right. You can see the excitement etched in all of your faces underneath your masks. Of course, yes, the project is due today. I made it due today, right at this exact moment at 9:30. If you have not turned in said project, I strongly urge you to do so, only because you need to get something for this. This project, fairly straightforward. Not as many people contacted me as I would have hoped. In fact, if I looked at the list, compare it to the number of people that I actually have enrolled in this class, it looks like roughly 19 to 20 people contacted me. 19 to 20 people contacted me when I have, let's see here, 42 students enrolled in Algebra 2. So those numbers are not great, but whatever. The due date was today, but of course I do accept late work at a price. Make sure you get that stuff in if you haven't already, and email me if you have any questions. In the meantime, quick question. Wednesday and Friday, did they actually have like substitutes, or did they get like teachers to cover the class? Wednesday and Friday, did they actually have like substitutes, or did they get like teachers to cover the class? Oh, Olmanchek. Yeah. Okay. Okay. All right. Yeah, there's not a lot of subs going around. I fully expected to be here last Friday, but I got to tell you, on Thursday evening, I was just sitting at the kitchen table, and my whole body was just like aching. And I was just like, I feel like I'm going to fall out of this chair. I really feel like I could feel it down to like my fingernails. Took some ibuprofen, probably passed out at some point. No idea. Some people have these weird effects. It's like what they told me was that the second dose of the vaccine, your body thinks it has COVID. And so it reacts accordingly. And I'm like, okay, still waiting on them superpowers, but we'll see what happens. Anyway, here's the plan. I gave you a review last Wednesday that most of you did. I would like to review said problems from that review. I would like to go over said problems from that review, and I would strongly encourage you that whatever you can write down from this review and refresher that we're about to do, that you do so. Because I am gearing up for a chapter assessment. I am gearing up for a major assessment for this particular chapter that we have been covering with exponentials and logarithms. Obviously, the project is going to count as a major, but I wanted to actually get in another major as well, especially through, let's say, something like Edulastic. And I would like to review for that. So last week you worked on something. On Friday, I gave you an opportunity to continue working through those projects and to finish that review if you hadn't done so already. And now today, I would like to go over those problems. So if you would, if you do not already have them out, I'm going to strongly suggest that you have those notebooks out and open. For those of you in the live chat, I see you there. Make sure you're leaving a comment, and I'll be checking that in a little bit. I can see what 6 people, 1, 2, 3, 4, 5, 6, 7. It's like 9 comments. Where are the rest of my people at? I don't know. Maybe they're just leaving comments and then ditching town. Who knows? Let's see what we got. Let's see here. Now, first of all, let's see. The assignment that you had to do was right here. I want to open that up on this PDF tab. There we go. Come on. Boom. And this doesn't go away at some point, but whatever. Actually, does it? I don't think it does. Anyway, but the problems that you had to do were these. Now, I'm going to keep flipping back and forth to this page so I can see precisely which problems that we need to be working on. I'm going to be giving some additional information, advice and suggestions and tips as we go through these problems. If you do have any questions, of course, I would like to go over them as best we can during this class period. For those of you in the chat, I'm currently getting the chat open on my phone so that I can see what questions you may end up having. There we go. So let's see what we can start with. Now I'm going to flip over to this screen. Oh, it's frozen like my heart. There we go. Today is the 23rd. And this is the Chapter 7 review. Now, obviously, working on your project was also a good review for this particular chapter, but I wanted to make sure that I went over those problems from that review so that we were all on the same page. So let's see what we got here. So just for the sake of argument, I had you guys do numbers 1, 2, 3, 4, 6, 7, 8, 9, 12, 13, 15, 16, 20. We'll start with 1, 2, 3, 4 on this one right here. Now, for those of you in the live stream, I understand that it can be difficult to see all of this very clearly. It is quite difficult to see all of that right away. So what I am going to do is I'm going to copy the link. There it is. I'm going to copy the link and put it into the live stream of the assignment so that you can open up the PDF so that you don't have to strain at the screen, so that you have your very own copy as well. Let's start with something like number 1. Now, for number 1, I'm just going to write down a few things into this little review notes thing that I got going on here. Boom. Not that one. There it is, this one right here. I'm going to start by writing down this information. This is the equation that they gave you for number 1. Y equals 4 times 2 to the x power. Now, this is in the form of y equals a times b to the x minus h power plus k. We had written that down a long time ago. But this is technically the general form of an exponential equation. The h and k simply act as numbers that shift this thing in the horizontal and vertical direction. The k is something that is very important. That k value is something that is referred to as the asymptote. In fact, I'm just going to put a little note for myself right here. This is the asymptote, whatever number that ends up being. The asymptote is the invisible barrier that the graph will approach but never actually cross. In a lot of cases, the asymptote ends up being 0, as it is for this particular equation. The asymptote is 0. Let me bring this back here. So for this problem, if I could zoom in just a tiny, there we go. They want you to do the domain and range of this particular function. Let me put this function into my calculator real quick. Yeah, let me put this function into my calculator real quick, just so I can see what the heck is going on with this thing. Come on, you. Loading. There we go. Clear that. Y equals 4 parentheses 2 parentheses to the x power. X power. There we go. Now let's graph this sucker. Nice. Question. Is this a growth or a decay? How do you know? Just because it's going up doesn't necessarily mean it's a decay. I'm sorry, a growth. You said growth, which I agree. This one is a growth. I ask why. He says because it's going up. Repeat that one more time. Kind of. How about this though? This, what I just drew in red, is also a growth. It is 100% also a growth. Now, you mentioned coming from the left side. What do you mean? So it's starting from like a flatline position from the left, you mean? You could think of it like that. You could definitely think of it like that. And if you thought about it like that, you would be correct. You would be correct. The way that I typically think about it is I read these graphs from left to right. I read them from left to right. And if I read them from left to right, are they growing exponentially? And if they're growing exponentially, it doesn't matter if left to right it's growing up or left to right it's growing down. It doesn't matter. It's still a growth. You can have negative growth. You can absolutely have negative growth. Think about national debt, for example. That is an exponential growth in the negative direction. I bring that up because this problem that we're working on, this one right here, is an exponential growth. I'm just going to sketch it out right here, and I would ask that you do the same. I'm just sketching it. I'm not doing anything fancy. I'm just sketching what it looks like. Because this problem just wanted to know domain and range. And yes, if you go to the left, it's flatlining. Do not make it curve back up. Do not make it curve down. It flatlines. Because that graph is approaching the asymptote. In this case, the asymptote is the value of 0. The horizontal line y equals 0. This graph stretches forever to the left and forever to the right. It does. Forever to the left, forever to the right, which means the domain of this particular function is negative infinity to infinity. And I'll show you what that looks like because the multiple choice answers didn't give you that. but you'll be able to recognize which one it is. But if you're talking domain, you're talking x-axis. If you're talking domain, you're talking left and right. If you're talking range, range is how far up and down. Now, yes, this thing goes up forever. But what the heck happens going down? Now, I've talked about this example a number of times in regards to exponentials. The fact that this graph, because the asymptote is 0, it will never actually equal 0. It will never reach 0 going to the left. It will never cross 0. It will never hit 0. But it will continually get closer and closer and closer and closer forever. So, the range in this case, you should write it like this. That's an infinity symbol. It's a weird looking one, but it's an infinity symbol. Notice I put parentheses around that 0. Parentheses imply that it's not actually going to get there. Putting those parentheses around that 0 means it's never going to equal 0. It will just get infinitely close to 0. What grade were you guys in when you first learned like inequality symbols? Like, did you ever learn it as like alligator teeth or some junk like that? Do you remember what grade that was?
Yeah.
Okay. Did you ever in that grade level, did they teach you where they put the line underneath of it to be or equal to? Yeah, because it's interesting. The reason why I bring that up is because of the choices that they give. The choices that they give you on this problem. Somebody in my hallway making noise. Anyway, the answer to this particular problem is this one right here. It's B. And the reason why I bring up that little line is because of the range that they have here. The domain is all real numbers, and that is what we wrote down for negative infinity to positive infinity. That's all real numbers. But the range we put from 0 to infinity, but we put the parenthesis around that 0, and that's right here with this y is greater than 0. Y cannot be equal to 0, but y is greater than 0. Oh, Joe says 5th grade. I don't know. You guys said 3rd grade. It's elementary school. I know that, you know. I don't know. There's so much math underlying that statement, though, about inequalities. There's so much math behind it. Goodness. There's a lot of stereotypes about people in like academic fields, like the depressed writer, the mad scientist. They all have to do with like mental illness. In mathematics, people usually end up in insane asylums. The man who studied infinity, there was a German mathematician by the name of Gregor Cantor. You can look him up, Cantor, Kantor, ended up in the insane asylum because of his study of the infinite. It's pretty insane. That you can't lose your mind if you never had one. You know, I once had, in this room for mathematical purposes, I once had a bag of marbles. I have no idea where in the room they are. There you go. Back to this. Number 2. Now, I'm not going to write anything down for number 2, but I'm going to zoom in just a little. I'm going to zoom in a little bit more. There you go. Number 2 right at the top. Again, a little difficult to see. I'm not going to write anything down for this one simply because you can recognize what it is. Actually, you know what? I might write something down for this. We'll see. But they want to know which one of those is an exponential growth. I'm going to change the question slightly. Which one of these choices is not an exponential? Which one of these four choices for number 2 is just flat out not an exponential? 3 of them are. 1 of them is not. Ooh. Which one of these things is not like the other? I'm not going to sing the song. That'd be silly. I mean, I already know what the answer is in terms of the exponential growth. I mean, I know what I'm going to write down in regards to that. But there is one key definitive feature that I need you to recognize. What makes an exponential and what doesn't make an exponential? Oof. Let me go to my notes real quick. I decided I am going to write something down for this. Here we go. Nah, frozen again. Ba-pow. First of all, the basic exponential function, where is the variable of x? Where is it? Where is x? Question mark. It's in the exponent, yeah. In the exponent. That is why they call them exponentials. That's why they call them exponentials. The variable of x is in the exponent. Now, if you go back to these choices, if you go back to these 4 choices in number 2, the only one that does not fit that categorization is G. G is the only one that is not an exponential. In fact, if you were to try and graph all 4 of these, 3 of them would look definitively like exponentials, having that flatlining occurring at some point. But G would not. In fact, I won't show you all 4. I'll just show you G. 4x to the 4th power. That's not an x. X. There we go. Let's see what it looks like. Graph. Clearly not an exponential. Clearly. But the problem wanted to know which one was an exponential growth. Well, that is where I come in here. You will have a growth. The value of b is greater than 1. You will have a decay if the value of b is between 0 and 1. You can recognize what is a growth and what is a decay based on what the value of b is. You have to know what the value of b is. Let me ask you a question. What can b never be? According to this, you'll have a growth if your b value is greater than 1. You will have a decay if b is between 0 and 1. So I ask the further question, what can b never be? Can't be 0. You will not have an exponential if you have b is 0. What else can it not be? Cricket, cricket. Ooh. You know what happens when you let b equal 0? Watch this. If you let b equal 0, I'll do the first one here. 0 to the x power. Watch what happens when I try to graph this with my b value being 0. Click. Oh, snap. B can never be positive 1. If you try to let it be positive 1, this is what happens. Not an exponential. Watch what happens when I try to make it negative. This is actually really insane. Watch very, very closely. Watch very, very closely what the calculator tries to do when I put in a negative 1 here. Do you see them? They're like little scattered dots. It's like, that is clearly not an exponential. Clearly. B can never be 0, it can never be 1, and it can never be negative. Otherwise, you don't have an exponential. The answer to number 2 should have been J. J was the exponential growth. The only number that matters is the number that is underneath the exponent. It is the only one that actually matters. For number 3, they gave you 2 ordered pairs. And they wanted to know, which one of those functions passes through those points. Well, it's a simple matter of this. Well, look, there are my 2 ordered pairs. I'm going to take each function and I'm going to plug in the value of x, and I'm going to see if I can't get the value of y. So if I plug a 0 in for x, 6 to the 0 power is 6. Or, I'm sorry, it's 1. It's 1. And then times 4 is 4. Oh, look at that. You plug in a 0, and you get 4 back. There's the 0. There's the 4. Let's see if it works for the 1 and 24. 4 times 6 to the first power. It'd be, well, 6 to the first is 6 times 4 is 24. There is the 1, 24. That is the answer, by the way, this one right here. That's the function that works for both. Plug in the x value. See if it gives you the y value. It's got to follow the order of operations at that point. Number 4. I am definitely writing down number 4. I am definitely writing down number 4. Simply because this problem is something that we have done in the past. There we go. There's number 4 right there. You have to solve for x. You have to get x by itself. When you have x in the exponent, usually logarithms are what we need. However, you actually don't need to use logarithms for this problem. And the reason why is because you can manipulate the way the problem looks in order to get the same base on both sides. There is a side note that I want to put here, and I'm literally going to call it a side note, and I'm going to write it on the side. Side note. If, I believe I did it as a to the x equals a to the y. If you have 2 things that have the same base equal to one another, then you can say that x equals y. You okay? Having a conversation? I don't even know. If you can get the bases to be the same value, then you can say that the exponents are equal to one another. This is something, again, that we have wrote down quite a while ago that we had practice with extensively. So I look at this problem, 8 and 32. The biggest mistake that you can make is by thinking, oh, well, 8 times 4 is 32. I mean, that statement is technically a correct statement, but it's not correct for this problem. You can't just say, oh, well, 8 times 4 is 32. I got to get the bases to be the same. No, you're going to have to re-express them using exponents. You're going to have to re-express them in the following way. You're going to have to re-express them in the following way. Because this whole thing has to do with exponents, you need to re-express the bases in terms of exponents. It shouldn't take more than a few moments to realize that, well, with a calculator, I could take 8 and break that thing down to be 2 cubed. And with 32, well, let me go to my calculator. I go to my calculator and try to break down the number 32. It doesn't take that long to figure out that it's 2 to the 5th power. And because of that, I am on my way to using that side note. I'm not there yet. I have to take one more extra step. You tell me, what the heck did I just do to the exponents? What in the heck did I just do to the exponents, allowing me to get rid of those parentheses? I did something. Something insane. Or silly. I don't know. One of the three. Power of a power. What did I do? What operation did I use between the exponents? I can hear the crickets, although they're probably dead from the winter. I don't know. Anyone have a cat that hunts crickets? My cat, when it's cricket season, and we wake up in the morning, we find cricket pieces around the house, like legs. One time we found a cricket. It had dragged itself about 3 feet away from its limbs. I'm not even kidding you. My cat, quote unquote, kills crickets just enough where they're still kind of alive. It is. It's a serial cat. Anyway, back to this. Yes? No, but that's a true story, though. It really is. Hold on. What's this announcement? That's not me. Yeah, she's new. Anyway, back to this. I multiplied them. I had to multiply the two exponents together. She said it in the chat. See, why aren't you here? She said distribute. Technically, that is what I did. I technically distributed the exponents like this. I took the 3 and I distributed it to the x and the 2, and I took the 5 and I distributed it to the 2x and the 4. I'm sorry I didn't see your comment. I was too busy talking about my serial killer cat. But seriously, he's a serial killer cat. Not even kidding, man. He also likes water. You know a cat that likes water? He literally will just sit in the sink with like water dripping on his head. Back to this. From here, I can use that side note and I can actually set the exponents equal to one another. At this point, it's like an algebra 1 problem. Move the 3x over, move the 20 over. I'm going to assume that we can jump straight to that. X equals -2. Now, of course, you can check your answer by plugging that back into the original problem. That's perfectly fine. That will work. I guarantee you it'll work. But that is the answer to this problem. Chapeau. Oh, not that one. I just wanted to see the choices. Yep, number 4. The answer was F. Now, I had you skip number 5. And let's take a look at number 6. Actually, before I talk about number 6, I'm going to write down another property for you. There it is. Cool. I have all these YouTube videos. I have a ton of YouTube videos. But the YouTube video with the most views on my channel is one of our late cat smacking a vacuum cleaner. He's seriously smacking it for like 30 seconds. And it has over 100,000 views. Yeah. What are people doing with their lives? I post a 30-second video and it's watched over 100,000 times. I probably watched that video like twice. Anyway, back to this. Exponential form versus log form. I show you this as a basic reminder as to what we have been doing. What we've been doing for the past many weeks. Preparing for your project, preparing for this major, preparing for everything at the end of this chapter. We needed to compare these two forms together, exponential form and logarithm form. These two are equivalent to one another. They're both technically saying the same thing, just from opposite sides of the coin. Exponential form has a base that is underneath the exponent. Logarithm form has that same base as a subscript. The whole purpose of logarithm form is to allow you to get the exponent by itself. And then ultimately, the resulting number or value of y is what goes in the logarithm's parentheses. If you can remember the base and the exponent, then you should be able to remember that the remaining number goes in the parentheses. I bring all of that up for number 6 on this particular review. Flip back. Number 6, let me scroll. It says to write 4 cubed equals 64 in logarithm form. Now, if you look at all 4 choices, they have numbers all over the place. Different bases, different equals to, different within, well, the imaginary parentheses. The base that is on the exponential is the same base that is on the logarithm. When you get to logarithm form, you need to remember it gets the exponent by itself. The exponent by itself. And then ultimately, the only number we haven't used is 64. That goes in the parentheses. I'll show that on the calculator in a moment. I'll show how that works. But this is the answer to the problem. You have to recognize where things are supposed to go. If you look at the choices, the only one that works is J. The only one that works is J. All the other numbers are mixed up in different orders, but J is the one that is correct. On the calculator, obviously 4 cubed is clearly 64. But then, if you go log base 4 of 64 should give me 3. It are inverse operations of each other. That is what they are. Inverse operations of each other. They basically undo each other. Number 7. Now for number 7, they want you to write this logarithm in exponential form. This one actually is a bit more straightforward. It's like, oh, I have to rewrite log base 12 of 144. Well, I know that 12 squared is 144. Yes, 12 squared is indeed 144. And that is the exponential form of that problem. The base on the logarithm, the base on the exponential. The exponent by itself, the exponent in the exponential. That is the relationship between these. Then for number 8, they actually do want you to evaluate that thing. They want you to evaluate that thing. Now for number 8, I'm going to do this in 2 different ways. One way is like, all right, that's what you do on a paper, I guess. And the other way is just on the calculator. Check this out. You could set this equal to x. Then you could rewrite it. You could rewrite it in exponential form. you could rewrite it as 2 to the x equals 8. Then, oh, well, there's only one number that makes that true. It's got to be 3. Now, I'm going to show you that on the calculator in a moment. Just again, to show you how it can be done. Of course, you do have a log button on your phone calculator, but this calculator is quite nice. Log base 2 of 8 is equal to 3. Technically, and I am going to be showing you this in a little bit. I've already shown it to you a bunch of times already. But you could also do that calculation. The door. But yeah, I will show you how I just did that on the calculator in a little bit, because there is a problem coming up with common logarithms. But let's look at number 9. Because unfortunately with number 9, you can't just type this into the calculator and hope for the best. With number 9, you actually have to convert it to exponential form in order to properly do the problem. If I were to convert log base 3 of n equals 2, the base, the exponent, equals the leftover. Oh, 3 squared is 9. Yes. 3 squared is indeed 9. That's all you would have to really think about. You have to make sure you understand the relationship between logarithms and exponentials. It's going to go a long way towards solving these problems. A very long way. Let's see what we got. I skipped to number 12 at that point. Yes, I skipped to number 12 at that point. Perfect. Let's talk about number 12. This utilizes a logarithm property that I taught you early last week. Flip that over so you can see that a little bit better. Now, I'm going to tell you right off the bat, just by looking at the problem, just by knowing how that property works, and I'm going to show you how I know this, but just by looking at it, I know that the answer is 4. I know without a shadow of a doubt the answer is 4. Done. How do I know that so easily? How do I know that without actually doing any of the math work? It has to do with the logarithm property. You guys remember the story I told you of my niece pretending to be a deer and wanting to get her belly cut open? Yeah, the innards. Yeah, the innards. When I add 2 logarithms together, I can combine their innards. How can I combine their innards? What do I do with this 10 and this x that allow me to combine them? Ooh. You remember the story of my niece, though? Yeah. Oh, I'm trying to do a flashbulb memory. You know? I can combine those 2 logarithms into a single logarithm. They have the same base. Because they're being added together, I can multiply their innards. Because they're being added together, I can multiply their innards. I told you I had deer jerky once. Yeah. It's okay. You know what's disgusting? Slim Jims. Has no one ever had a Slim Jim?
I mean, they're okay.
They're not like.
I wouldn't go out of my way to buy one.
Yeah, I wouldn't go out of my way.
I would. No, I would toss it aside. I would take their generosity and throw it back in their face. Just saying. Give me real beef jerky.
Yeah, the beef jerky.
Just saying. But deer jerky was okay. Just saying. Anyway, back to this. Combining the innards. Notice that they both have the same base. Oh, Joe in the chat says they're pretty good. I'm assuming he means Slim Jims. I'm going to tell you, Joe, just so you know, we've all decided to not talk to you because you like Slim Jims. Anyway, because they have the same base, I can simply do something like this. Once you recognize that this problem is nothing more than 10x equals 40, then you can hopefully recognize how I knew the answer was 4 without even skipping a beat. You have to recognize how that property is put together. You have to recognize that if you're adding logarithms, you can multiply their innards. Paper. I have never gone hunting, but I feel like if I were out there and there was like a wild animal in front of me, I don't think that I would have the guts to end it. I'm just saying, I'm just being completely honest. I know who I am. You know what I'm saying? I don't think that I could do it. I don't think that I could actually pull the trigger. Oh, if it's a bear trying to kill me, that's a different story. If it's like a deer in like, you know. I don't know. Have you eaten duck? It's so greasy.
It's just like duck season.
There's a super fancy restaurant that gave me duck dumplings.
They're very greasy.
It was disgusting.
Yeah.
Mr. Mike, what if the duck is trying to kill you?
It depends. It depends. How is the duck going to kill me?
What would you do if a duck tried like biting you or something?
Have you ever heard the analogy of like, would you rather fight 100 ducks or one car-sized duck?
A car-sized duck, you could just punch it in its nose and run.
Just saying. Have you seen not about ducks, but have you seen like pictures of geese and their teeth?
Yeah, just grab it by its throat and swing it.
Just saying. Hold on. Now I got to Google this. Hold on. Hold on.
There was a bunch of geese at the pit and they hissed at me and I just walked and ran away. I'm not like
Hold on.
chase after little kids.
Look at that.
That would not hurt.
I'm just saying that's freaky, dude.
I'd want the smoke. I'd grab it.
Yeah, you could just grab it by its throat and swing it around like a lasso.
Anyway, back to this. Oh, goodness. Number 15. Actually, no, number 13. I apologize. 13 I had to do as well.
Bro, I was at the pit and there was a whole set of deer bones like scattered everywhere. And then there was the fur spread all over the place.
Where is there a pit in Barnegat?
Well, they just like put it down.
Where in Ocean Acres?
We saw a bunch of
Like, you know where Savannah is?
Maybe. Is that one of the side streets that take you like to Nautilus?
Yeah,
Off of Nautilus.
Go down Nautilus. It's like 4 streets down on the right.
Okay.
Basically, you just go
No,
down.
I live in Manahawk and Ocean Acres. That's why I asked. So I'm not as familiar with that side. No, I'm just thinking like pits in Barnegat. Like I used to know like you know where the Walgreens is, right? Right now you could see it's like they're building like crazy back there, right? Back in the day, that was just like nothing but grassland and dirt and trees, nothing back there. And there was a theory about 25 years ago, maybe more, maybe like 30 years ago. There was a theory that Barnegat had put in a bid to try and get a minor league baseball team. And that's where they were going to put it.
Really?
Yeah. Now, obviously, we never got that bid, but that team ended up being the Lakewood Blue Claws. Yeah. Would that have been awesome?
Yeah, there's just nothing down here except for just a baseball team.
Yeah. Well, there's me. Hey, they've won their championship a few years in a row. I once went to a playoff game with them. I took my dad because we had never been to a Blue Claws playoff game. Pitched a no-hitter. They won their division championship as a result. It's awesome. Back to this. I got to solve this. I got to solve for the exponent. I got to get the exponent by itself. Yeah, Joe, they are. Yeah, Joe's commenting about them building houses there now. But yeah, pretty crazy. Well, see, the interesting thing is, before 1980, there was only about like 1,000 people living here. Before 1980. My parents moved in 81. Now there's over 25,000 people living in Barnegat. Anyway. Oh, yeah. If you convert this thing. Wow. I don't know who you're threatening, but. Goodness. If I convert this thing to logarithm form using the proper base, getting the exponent by itself, then I can utilize the calculator to do this for me. I can utilize the calculator to get that done for me. Log base 4 of 20 spits out the exact decimal that I need. Do you know the story behind that?
No.
You really don't? You don't know the history behind it? There was a magazine in the 1970s. I think it was called like High Magazine or High Times or something like that. And there was a story run about a group of guys who, after school, every day they would meet up and they would just get high, right? Well, the meeting time was 4:20. And it was an article written for that magazine. And it was just like this small group of guys that did that. But as a result of that magazine, eventually other groups kind of took up the cause. TV shows and movies kind of alluded to it, kind of on the, kind of vaguely alluded to it. And then eventually, fast forward 40 years, and now it's just like a joke. Yeah. Yeah, but I know now it is. But I'm just saying, back in the day, it was literally just when these guys, they would meet up. And the reason for the time was because it was after school. I don't know. It's also Hitler's birthday. No, 420. That's a coincidence. Pure coincidence. Anyway, back to this. Number 15. Number 15, I do have to show you one quick thing before we talk about number 15. I have to remind you of this. I've written this down before. I've used this multiple times. But you need to remember this conversion. Now for this one right here, notice I did not put a base in for that log. If I don't write a base there, what do you assume it is? You say it again one more time? 10. Also known as, do you remember the name for it, the nickname? It was the what logarithm? The common logarithm. It's known as the common logarithm. Base 10, yes. And if I go back to this problem, I'll come back to this in a moment, but if I go back to this problem for number 15, notice for number 15, it says to express it in terms of common logarithms. This is the change of base formula, where you can turn any logarithm into common logarithms by simply taking log of C divided by log of B. I always remember it by saying that the base goes on the bottom. So for this problem, they want to know log base 9 of 22. And as long as you know that formula for the change of base, it's just log of 22 divided by log of 9. That's all that it comes down to. And you can convert a log base 9 into a log base 10. And the calculation's done. If I look back at the choices, which I am going to in a moment, if I look back at the choices for that problem, the answer is C. It has to be. It has to be in that particular order for common logarithms. Very strange. Log base 10, just going to remind you again because this is a review. Log base 10 is the common log. That is the common log. Do you remember what I called log base E? Log base E. We called it the natural log. Log base E, just as a reminder, is the exact same thing as the notation ln. Log base E and ln are exactly the same thing. You have an ln button directly on your number 16. Number 16 wants you to calculate the following. E to the ln of 4 power is what? I literally would just go to the calculator with this. But notice that an exponential with base E, an exponential with base E, a logarithm with base E, watch what the calculator says. E to the power of ln of 4. They cancel each other out. I could do it the other way too. ln of E to the 4th power spits out the same number. Doesn't matter which way I do it. But I need you to recognize that ln is log base E. It is log base E, and you have the ability to do that directly on the calculator. Okay. I'm going to stop it there and remind you of the following. I am going to be assigning you an online assessment in regards to this chapter, in regards to everything that we've been doing, in regards to exponential word problems like you've had on the project and like we've done together in the past. I will be assigning that within the next day or so. If you do have any questions on that, please make sure you ask me. Spring break is soon. The bell is almost here. Now. I was off by half a second. The clocks are off. Half a second. Come on. Anyway, I'm going to sign off in a few moments. If you haven't left a comment in the chat, please make sure that you do so. I can see all your wonderful comments right there. And I'll end it there.